What are a couple of things that you've learnt to do with this prime factorization? Okay, you've learnt about this thing called the highest common factor. Okay, highest common factor. So for instance, we know the prime factorization of 24. Okay, let's do the prime factorization of 100. Okay, now what was I asked to do? Oh, right, hold on. Let's make it like that.
You can use it.
Hold on.
It's fabulous. Wow.
Wait, hold on. Where's the... this is gonna work.
Don't worry, nothing to do.
There we go.
Yes, and then
Oh no, I missed!
Undo.
I'm just gonna leave that if that's okay.
And then you can make it really green if you want.
I don't trust my aim enough. So I'm gonna go back. Who wants to give me a some factors? Yeah, Liam. 2. And, oh, that was a good mess. 2 and 50. Now, by the way, well, I keep doing this. 2 and 50. You could have picked. What else could you have picked?
Yep. 10
and 10. Okay. Now, I actually think 10 and 10 might have been a better choice. Now, here's why. Like we said. Like I said, if we'd chosen 2 and 12 or 4 and 6 and 8 and 3, we will end up at the same spot. And that's one of the important things. The prime factorization is unique. There's not like a whole bunch of different ones. There's only one. Okay? But 10 and 10 would have been better. Can anyone suggest to me why? Yeah. Okay, so did you catch that? So let me repeat it because it's really important. Okay? And it will save you time in the future. 10 and 10 are a better choice because, let me actually write it. Let's change these here. If I make this 10 and this 10, okay? Now, once I know the prime factors for this, I already know the prime factors for this. And I've done it twice, right? So if I've done it for 10, right? Well, okay, what are the two factors? 2 and 5? I don't need to do any more mental work, right? Because I've already done it for these two. Whereas for 2 and 50, I'd have to think about 50, and then I got to think about 25, or 5 and 10, or whatever. Okay. Whereas here, I'm done. I'm finished. Okay. So therefore, what should I write? I can say 100 is equal to 2 squared times 5 squared. Good. There you go. Okay. So now I can say, all right, what is the highest common factor? Right. And you remember, I'm not sure if you got shown. There's a way to write this, right? The highest common factor of 24 and 100. What's it equal to? How do we find it? Jasmine. Okay, so I've got my factor trees now. There's one. I should have made them smaller, but there's this one, and there's this one. So what do I do with them? I'll write here, 24 is 2 cubed times, what did we say? 3. Okay, good. Now what? Yeah, Rashad.
I think we see what ones are the same on both factor trees, like what numbers.
Good. So I'm trying to look for, see these things are the factors, right? So I want to look for the ones that are in common. Okay. So for instance, the 3s and the 5s not in common, so we forget about them. Okay. I've got 2 2s here and I've got 3 of them here, right? So how many am I going to get that are in common? 2. So it's 2 squared, which is 4. Does that make sense? Okay. See that? See what I did? Okay. What am I looking for? I'm looking for the highest common factor. What does common mean? No, seriously, what does common mean? It's in both. That's exactly right. There's a 3 here, but it's not here. So it can't be common.
Yeah, I agree with you.
There are 5s here, but they're also not in common. So they can't be part of my highest common factor, right? Now I can't pick 3 2s because I don't have 3 here. There aren't 3 in common, right? There's only 2. Okay? So that's why this is 2 squared, which is 4. Make sense?
Yeah.
Okay. How do I do the lowest common multiple? How do I do this? This is tricky, isn't it? Lowest common multiple of 24 and 100. How do I work it out? Yeah. Okay, so let's do that, shall we? I'm going to circle all the ones that are the same. Okay, so far, I've just got that 2 squared. That's the same. Yep. Okay, so if I cross 2 of them out here,
Paparazzi.
So let's rehearse what we've done. We've got the 2's in common. I crossed out one of the 2's here. Now what? Okay, so I've got this 3, and I've got the 5 square, and I've got the 2. Okay, so I'm going to take the lot, and I'm going to multiply it all through. So let's write that. Did I miss? There we go. Okay, so I've got 2 cubed times 3 times 5 squared. That's a big number, isn't it? Can we work it out?
Yeah.
Can we work it out? You got your calculator there? I'm guessing it's 600. Is it? Is it?
Yeah.
There you go. And by the way, just in case you're curious, the way that I did it is I said, well, this is 24 times 25, isn't it? 24 times 25. But when you learnt your times tables, I'm not sure how many of you learned that 25 times 25 is 625. That's an important one, right? So if I've got 24 of them, that's one less, isn't it?
Yeah.
25 less, so that's how I got to 600 so fast.